Hey, Honors Geometry, welcome back to another video. Today we'll be talking about some symbolic logic. So symbolic logic really is about two main things. We're going to be talking about conjunctions and disjunctions. So let's break those words down, we'll figure it out, and then we'll move on to what those truth tables will look like. So this first one, we're going to be talking about conjunctions. That is a statement that combines two pieces of data with the word and. So for example, your parents might ask you, I need you to clean your room and do your laundry. Now I know you all are wonderful children, and so you want to make your parents happy. And so you'd want to do both of those things because you want them to be happy with you. So this statement, a conjunction, can only be true if both pieces of data are true. Now, just to let you know, when we write these out, we're going to be talking about our P and Q. The way we talk about a conjunction is like an uppercase A without that middle line, kind of a pointed upside down V. Now, it's going to be a little tricky because our disjunction, I'll give you a little bit of spoiler, our disjunction symbol is going to look kind of similar to that. The way that I think about this is if it's like a roof over a house, right? We have our symbol, and it's containing everything inside of it. The and includes everything inside the house. All right, let's talk about disjunction. This is a statement that combines two pieces of data, but it uses the word or. So for example, if your wonderful parents said, I need you to either clean your room or do the laundry to get allowance for the week. You don't have to do one of those things for you to be able to get the end results of getting an allowance. And so a disjunction can be true if at least one of the pieces of data are true. So you only need one or the other for the entire thing to be true and to make your parents happy. And so for this symbol, like I said, it's going to be kind of similar. It's going to be a bigger V. The way that I remember this is that this V kind of has two branches going down, and we're coming to the same correct solution. It's coming down, there's two ways to get there, but we end up at the same spot. So hopefully that makes sense. You'll get used to all those symbols later into the year. Let's scroll down and get to our truth table. So kind of like last time, we filled out this truth table by putting two truths here and two falses for our hypothesis. And then we alternated to be able to get all the different combinations of true and false. So we'll fill those in just like we saw last time. Now let's talk about this middle one. So this is going to be our conjunction or our and. So if we have a true and a true, so you did clean your room and you did do your laundry, your parents will be very happy with you. So this statement will be true. Now, spoiler alert, this is the only time that this statement can be true. If there's any falses in here, it's not going to be true. If you didn't do part of what your parents asked, they aren't going to be super happy. Let's move on to this next one. If our hypothesis is true, our conclusion is false, we didn't get one or the other, so this is going to be false. Same with this next one, not all true, and same with the last one, it's especially not true. And so for our and, it's pretty specific what is true, what needs to be true, and what cannot be false. Let's talk about this next one. This is our disjunction, or our or. So for example, in this one, if your parents asked you to do the dishes or clean your room, then if you did one of those things or both of those things, it'd be true. So this first one, you did both of them, so it's going to be true. This next one, you only did the dishes, but that's okay. They didn't ask you to do all of it. This is going to also be true. And same thing for this next one. The only way this one can be false is if you didn't do anything. And I wouldn't be very happy either. All right, let's go on to this next one. This is a little bit different. So this is with our arrow from before, our implies symbol. This one says P and Q implies P. So let's talk about the truth value, kind of like what we did last time. But I'm just going to real quick repeat these values in the top corner just so we kind of understand where we're going. So for our P and Q, I'm just going to copy down this column in the top corner. So we had true, and I'm getting this from this middle column right here. We had true, and then false, false, and false. And now it implies whatever our P is. And so again, I'm just going to copy down this column that we have right over here on the far left. We have true, true, false, and false. Now let's remember back to our last video that talked about our truth tables and when we have a truth value, whether it's true or false. So if we have a true hypothesis and a true conclusion, this will be true. If we have a false hypothesis but a true conclusion, also going to be true. It's that vacuous truth again. But if we have a false and a false, again, this will be true. And it's the same exact thing. And so all of these will actually be true. Okay, now let's think if we maybe had a third piece of data. So maybe it was like your parents asked you, can you clean your room and do your laundry and do the dishes? That's 3 pieces of data. If we want to make a truth table for that, let's go ahead and think about what that's going to look like. So we can go down to this empty table. It's just waiting for you to be filled in. And so we already know these ones. I'm just going to write them in really quickly. We had 4 columns, or rows, I'm sorry. So 1, 2, 3, 4. We had our true, and our false, and our false. Now let's say that our third piece of data, this was all true. We had true, 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 true. But our third piece of data could also be false. And so we have to account for all of those too. I'm going to draw in some lines here too. I'm going to say false, 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 and false. Now you'll notice, let's just repeat that same column from above down here. So it could be true or it could be false. And now you'll notice we're kind of alternating here. So in our first piece of data, we just split it up in half. So we did the first half of our options being true and our second half being false. Now if we look at our second column with our P's, we alternate every 2. So we do kind of half and half. So say half of those truths, we can also pair with another true statement from our P. The other half is going to be false, like you'll see here. We repeat it at the same time. And now this Q is just going to alternate. It'll be true, false, true, false, true, false, true, false. And so we won't have to worry about filling out these last ones. This is just to kind of get an idea of what we're looking at. So if we want to find the total true and false combinations for 2 pieces of data, this is what it looks like in this top section. We have 1, 2, 3, 4 rows. Now the way that we found that, which I just gave it to you, but the way that we normally find it is by having our 2 options, so it's true or false, or 2 possibilities, with how many pieces of data we have in the exponent. It's going to be squared. And 2 squared is 4, which is how we get our 4 rows. Now moving down to this 3 pieces of data. We still have our 2 options of true or false, our 2 possibilities, but instead of 2 pieces of data, we have 3. It'll be 2 cubed. And that'll be 8. And if you notice from our table that we just drew, we have 8 rows that are represented here. All right, there's this last one. This is if we have 5 pieces of data. Go ahead and take your best guess there. Should be just following the same pattern from before, and we'll check it when we see you next in class. Have a good day.